In the same chapter 1, we'll see the next concept, the next topic, then how to draw the ideal characteristics of various semiconductor devices. Understood? Okay. This concept is also very important. Already in so many competitive exams, already questions are framed based on this concept. In GATE and IES also, questions already repeated. Very important topic for any competitive point of view. Okay. Then how to draw the ideal characteristics of semiconductor switches or devices. Okay. Ideal characteristics of ideal characteristics of semiconductor devices or switches. Semiconductor devices or switches. Ideal characteristics of semiconductor devices or switches. First we will see. We'll start with first one is a diode. This diode is anode, cathode. In the drawing of ideal characteristics, mainly here ideal characteristics, we are drawing the VI characteristics. In drawing of static VI characteristics for any semiconductor device, take current on y-axis, voltage on x-axis. Okay. This is minus V, this is minus. It's okay. Here you are drawing the ideal characteristics means if the device is on state, what is the observations? Represent those observations. If the device is off state, what are the observations? Represent those observations. Here we are drawing the characteristics of a switch. A switch is nothing but a on and off state. On state and off state observations ideally we are representing. Okay. In the drawing of ideal characteristics or static characteristics of static VI characteristics of any semiconductor device, take always current on y-axis, voltage is on x-axis. Okay. But drawing of current characteristics are very simple. Simply you remember like this. If only one device is present, in some I want to give combination of devices also, that you will see. If only one device is present without any anti-parallel device, there is only one device is present, then always the device will conduct only in one direction. If only one device is means it conducts only in one direction. Okay. Then you take here you have only one device now, that's why you take it conducts only in one direction. That is a forward current. It allows the forward current. That means diode allows the forward current. Then how to draw the voltage characteristics? Now see, for this diode, if VAK anode to cathode voltage is positive, if anode to cathode voltage is positive, then diode is forward bias. Then if the diode is forward bias, it starts the conduction, it conducts. Diode will conduct. That means diode cannot block the forward voltage. That means we don't get any characteristics this side because it is a positive voltage. If any forward voltage or positive voltage is applied across the diode starts the conduction. When the diode starts the conduction means it acts as a closed switch. Once it acts as a closed switch, is there any voltage blocking of diode? No. Understood? That's why it cannot block the forward voltage. For same diode, if VAK is negative, anode to cathode voltage is negative, then diode is under which condition? Reverse bias condition. If the diode is under reverse bias condition, it conducts or blocks the voltage. Diode is under reverse bias condition means it acts as an open switch. Then it blocks the voltage. That's why the diode blocking positive voltage or negative voltage. For positive voltage, it acts as a closed switch. It cannot block any voltage. For negative voltage, it acts as open switch. That's why it is blocking the voltage. That's why you can get the characteristics like this. Okay. This is the ideal characteristics of a diode. That's why a diode is the example of unipolarity. It blocking only one voltage. That is one polarity of supply. That is negative voltage only. Unidirectional. It conducts only in one direction. That's why a diode is this important observation. A diode is unipolarity. Unipolarity means only one polarity. That is negative voltage. Unipolarity. Unidirectional. Uncontrolled device. It is unipolarity, unidirectional, uncontrolled device. It blocks only one polarity of supply. It allows only in one direction. This is the ideal characteristics of a diode. Now see how to draw the ideal characteristics of diode. This is a representation of symbolic representation of diode. This one dash. In the representation of diode, we don't represent anode and cathode. Understood? We represent one dash here. We cannot say which is anode, which is cathode, because this side consists of both anode and cathode. This side also it consists of both cathode and anode. That's why we cannot represent anode and cathode terminals. It is represented with one dash terminals. Okay. What do you mean by DAC? A DAC stands for, it is diode AC switch. Diode AC switch. A DAC stands for diode AC switch. Understood? Understood. Then it is anti-parallel connection of two diodes. 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 In detail about this diode concept in separate session I will discuss. But here I am explaining the only ideal characteristics of devices. Okay. The anti-parallel connection of two diodes means the equivalent circuit is written like this, drawn like this. It is anti-parallel connection of two diodes. A diac is equivalent to anti-parallel connection of two diodes. Now I am drawing the ideal characteristics of diac. In the drawing of ideal characteristics for any semiconductor device, take like this. This is I, this is V, this is minus V, this is minus I. Understood? It is anti-parallel connection. I told already, if only one device is there, you take only one direction current, that is forward current. But if it is anti-parallel connection of two devices means, then the device will conduct in both. That's why you can get the characteristics in both the direction. Now, I want to draw the voltage characteristics. Tell me, if V11 dash is positive, what happens? If V11 dash is positive, if V11 dash is positive, if V11 dash is positive means V1 minus V1 dash is positive. If you want to make V1 minus V1 dash is positive means 1 is must to be positive minus 1 dash is connected to negative, then resultant is positive. Then V11 dash is positive means, then you connect like this. 1 is connected to positive plate. 1 is connected to positive plate. Yes, 1 is connected to positive plate. Like this. One dash is connected to negative plate. Then only it is a positive. V11 dash is positive. Then with this polarity, let the anti-parallel connection of two diodes now. Let this is D1, this is D2. Then with this polarity, tell me, this D1 is forward bias. 1 is connected to anode, 1 dash is connected to cathode. 1 dash positive forward. What about D2? The reverse bias. Okay. That means one diode is conducting, remaining diode is under reverse bias condition. But I am not talking about individual diodes. Here I am explaining the concept of diode. If one device is conducting, means the total device is conducting. If one diode is conducting means the total device is conducting. Understood? That's why for V11 dash is positive. That means if the positive voltage is applied to the diode, then diode is blocking or conducting. If one diode is conducting means the total device is conducting. That is the meaning. If this is conducting, sorry, this is blocking. If these two are in anti-parallel, if it is conducting means because these two are in parallel, the voltage across this diode is also 0 because it is parallel connection. That's why the total device blocking or conducting. Conducting. The total device is conducting. If one device is conducting means the total device is also conducting. That's why it cannot block. That's why diode cannot block the positive voltage. That's why we don't get any characteristics this side. For example, if V11 dash is negative, if V11 dash is negative, what happens? If V11 dash is negative, if V11 dash is negative, means we are applying the negative polarity. V11 dash is negative means this is the circuit. That is 1 is connected to which one? Negative plate. 1 dash is connected to which one? Positive plate. If V11 dash is negative means this diode is under reverse bias condition and this diode is under forward bias condition. This is 1 dash. Okay. But here this diode is conducting, but this diode is under reverse bias. I am not talking about individual diodes, I am talking about total diode concept. That's why the total diode is conducting or blocking? Conducting. If one diode is conducting means total device is conducting. That's why if it is conducting means it cannot block the reverse. That's why diode cannot block forward voltage, cannot block reverse voltage. That's why it is the example of bidirectional device. There is no any polarity blocking. That's why therefore a diode is a bidirectional device. Bidirectional device. It conducts in both the direction. A diode is the example of bidirectional device. Okay. This is ideal characteristics of a diode and this is the ideal characteristics of a diode. Ideal characteristics of a diode. Okay. Now we'll see another device. I think you know down this one. Okay. Parallelly note down. Then we go for another semiconductor device. What is the ideal characteristics? Third one, go for this is you draw the ideal characteristics of these devices. This is thyristor. In detail about these devices later on I will explain. This anode, cathode, gate. And the ideal characteristics of thyristor and GTO is same. That's why for both the device I am explaining. Okay. This is anode, cathode, gate, represent like this, or this GTO is also written, also drawn. The symbol for GTO is also drawn like this. Yes. This is anode, cathode, gate. This is SCR and this one is for GTO, gate turn-off thyristors. Gate turn-off thyristor. In detail about this SCR and GTO later on I will explain in the next sessions. But here I am explaining the concept how to draw the ideal characteristics. Okay, told already. In drawing of ideal characteristics of any semiconductor device, take current on y-axis, voltage on x-axis. Yes, these characteristics are same for both SCR and GTO. Tell, is there any anti-parallel devices here? No. If there is no anti-parallel device means you take only in one direction. The direction of current is forward or reverse? Yes, forward direction. This is under forward direction. It conducts only in one direction. Now, if VAK is positive, then Either SCR, GTO, both are under SCR or GTO. It may be SCR or GTO. Is under forward blocking mode. Initially first it is under forward blocking mode. When it starts the conduction, after giving the triggering pulse only. After giving the gate pulse only. Before giving the gate pulse, up to gate pulse is given, it blocks the voltage now. That's why it may be SCR or GTO, blocks which voltage? Forward voltage. It blocks the forward voltage. If VAK is negative, if anode to cathode voltage is negative, it may be SCR or GTO is under which mode? Reverse blocking mode. What exactly forward blocking, what exactly reverse blocking mode, all these concepts I will discuss in SCR and GTO. But here I am concentrating on the how to draw the ideal characteristics. Okay. Then reverse blocking mode means still it acts as an open switch. Open switch means it blocks the reverse voltage also. Therefore, either SCR or GTO is the examples of it blocks both the polarity, it allows only one direction. Therefore, SCR is the example of it is bipolarity unidirectional semi-control device. Okay. What about GTO? The GTO is the example of, it also blocks how many polarity? Two polarity. It is bipolarity unidirectional bipolarity, fully controlled device. Why it is a fully controlled? The definition of fully controlled I already given. Fully controlled device. Yes. Next, you draw the ideal characteristics of this device. If it is given like this. Thyristor with anti-parallel diode. Let this is 1 dash. This is gate. Don't represent with anode and cathode because of anti-parallel. Now, what is the ideal characteristics of this device? In drawing of ideal characteristics, take this is I, this minus I, V minus V. Understood? Okay. Understood? Here it consists of anti-parallel. I told already. If there is an anti-parallel means the devices will conduct in both the directions. You take the current characteristics. It conducts in both the directions. Yes. Now you want to draw the voltage characteristics. If V11 dash is positive, what happens? If V11 dash is positive means it is connected like this. No? If V11 dash is positive, no? One is connected to positive plate, one dash is connected to negative plate. Then only it is a V11 dash is positive. If V11 dash is positive, then thyristor is under forward blocking mode. Then diode is under a reverse bias condition. Then total device blocking or conducting. No device is conducting. If even one device is conducting, then you take it is conducting. But no device is conducting. Understood? That's why the total device is blocking or conducting. Blocking. That's why it blocking which voltage? Positive voltage or negative voltage? Yes, positive voltage. That's why we can get the characteristics this side now. We can get characteristics like this. If V11 dash is negative, now what happens? If V11 dash is negative, now what happens? If V11 dash is negative means 1 is connected to negative plate, 1 dash is connected to positive plate. Then thyristor is under reverse blocking mode, but diode is under forward bias condition. It starts the conduction. Now, here diode is conducting now. That's why the total device is conducting or blocking. Yes, it is conducting. That's why this device cannot block which voltage? Reverse voltage. Because if reverse voltage is applied, if negative voltage is applied, it starts the conduction. Okay. That's why it is the example of, what is this device's name? What is the name of this device? A thyristor with anti-parallel diode is called RCT. That is a reverse conducting thyristor. A reverse conducting thyristor. This is RCT. A reverse conducting thyristor. Reverse conducting thyristor. Then this is the example of which one? It is bidirectional unipolarity device. Bidirectional unipolarity device. Okay, the bidirectional unipolarity. The RCT is blocks one polarity of supply, allows in both the direction. One polarity. Which polarity it is blocking? Positive polarity. Okay. Then we'll see another example. Then you try to draw the characteristics of this device. Next one is fifth one. Try to draw the characteristics of this device. Yes. This draw the ideal characteristics of triac. Triac stands for triode AC switch. Triode AC switch. Triac stands for triode AC switch. Okay. Then what is the symbol for triac? The triac is triode AC switch. This is MT1 and this is MT2. That is main terminal 1 and main terminal 2. It is anti-parallel connection of two thyristors. It is anti-parallel connection of two thyristors. Connection of two thyristors. It is anti-parallel connection of two thyristors. Understood? It is anti-parallel connection of two thyristors. Then here, don't think like this. Here we have only one gate terminal. That's the reason why it is one thyristor, it is one diode. It's meaningless. Internally, this gate is connected to this also. That's why it is anti-parallel connection of two thyristors. The representation, the symbolic representation is also given like this. The anti-parallel connection of two thyristors. This MT1 na main terminal 1 and this is MT2 na main terminal 2. Main terminal 2. Okay. Then the gate is internally connected like this. Now you draw the ideal characteristics of this triac. This is I, this minus I, V, minus V. Okay, plus I, minus I, V, minus V. Because of anti-parallel connection, it allows in both the direction. Because of anti-parallel connection, it allows in both the direction. That's why characteristics. Yes. Now I want to draw the voltage characteristics. Now tell me, if VMT1, MT2 is positive. If VMT1 and MT2 is positive means MT1 is connected to positive plate, MT2 is connected to negative plate. Then what happened at the equivalent circuit? Then this thyristor is under forward blocking mode and this thyristor is under reverse blocking mode. Then the total device blocking or conducting? Blocking. That's why it blocks which voltage? Forward positive voltage. It blocks the positive voltage. If VMT1 and MT2 is negative, MT1 and MT2 is negative. If VMT1 and MT2 is negative means then this is main terminal 1, then this is main terminal 2. If you want to make negative means then MT1 is connected to negative plate, MT2 is connected to positive plate. Now this diode is this thyristor is under reverse blocking mode. This thyristor is under forward blocking mode. Then total triac is blocking or conducting? Blocking, because there is no conduction of any device. That's why it also blocks which voltage? Negative voltage. Then triac is example of which one? It's a bidirectional bipolarity device. It blocks both the polarity and conducts in both the direction. That's why it blocks both the polarity and conducts in both the direction. Okay. Therefore, it is example of a triac is the example of. Therefore, it is bipolarity. Bipolarity and bidirectional device. Bidirectional device. Bidirectional device. A triac is the example of bipolarity and bidirectional device. Next, the other types of devices. Sixth one. We try to draw the characteristics of these devices. Ideal characteristics of these devices. This is collector, base, emitter. This is gate, drain, source, MOSFET. All these devices having same characteristics. This collector, gate, emitter. This is BJT and this one is MOSFET and this is IGBT, insulated gate bipolar transistor. Insulated gate bipolar transistor. Metal oxide semiconductor field effect transistor. Bipolar junction transistor. In detail about these devices later on we'll see in different sessions. Okay. But here I am concentrating drawing of ideal characteristics. All these devices having same ideal characteristics. That's why I am giving here itself. Okay. Either BJT or MOSFET or IGBT. Is there any anti-parallel devices here? No. This I, this is minus I, this V, this minus. Understood? Now tell. There is no anti-parallel devices. That's why it allows only in one direction. It allows only in one direction. BJT, MOSFET or IGBT. For reverse voltages, it cannot block. Because if you apply the reverse voltage, the collector to emitter voltage, because you take collector and emitter. If you take the example of BJT, if you take example of BJT, that is collector, base, emitter. If you apply the forward voltage up to VCE equal to VCE sat, it blocks the forward voltage. Understood? Then if you apply reverse voltage, it cannot block the reverse voltage. Either BJT or MOSFET or IGBT cannot block the reverse voltage. That's why we don't get any characteristics in the negative side. If the reverse voltage is applied, we know that collector and emitter, those collector is highly doped. Sorry, this is emitter. Sorry, this is emitter. This is collector. Emitter is highly doped. Collector is moderately doped. So simply, it is emitter and collector is doping concentration is high. If the reverse voltage is applied, it cannot withstand more voltage. If the doping concentration is increases, the blocking voltage will be reduced. That's why this BJT or MOSFET or IGBT, you don't have any operation for reverse voltage. That it cannot block the reverse voltage. That's why simply remember like this. Either BJT or MOSFET or IGBT is operated in which quadrant? First quadrant only. Okay. Even you see in the characteristics in detail later I will give the characteristics of this BJT, MOSFET and IGBT also in detail, that in the operation I will explain. We know you have the if you draw the characteristics for BJT means we get the characteristics like this. This region is, this is which region? Saturation region. This is which region? Cutoff region. This is which region? Active region. Okay. But switch concept means you say you take saturation region and cutoff region. Cutoff region is, this is blocking voltage. Saturation region means this is conducting. That's why we get characteristics only in first quadrant. We don't have any characteristics. Understood? That's why either BJT or MOSFET or IGBT for the characteristics, it blocks forward voltage, allows the forward current. That's why inherently BJT, MOSFET and IGBT, it is the examples of, therefore it is unipolarity. It blocks only one polarity. unipolarity and unidirectional devices. Unidirectional devices. Unipolarity and unidirectional devices. Now, see the another device. Okay. For example, if the characteristics are like this, if the device is given like this, you try to draw the characteristics of this device. If any diode is connected, what are the characteristics of this device? Okay, same. Take drawing of these characteristics. This is I, this minus I, this is V, and this is minus V. You know this, we don't have any anti-parallel device. That's why we can get the characteristics only in forward current. Transistor blocks the forward voltage. If reverse voltage is applied, we don't have any blocking of transistor, but this voltage is blocked by which one? Diode. That's why up to this transistor this is okay. Then because of this series diode, it blocks which voltage? Reverse voltage. Extra we are getting this characteristics. That's why a transistor, a BJT or MOSFET or IGBT, not only for this BJT, you also connect MOSFET, you also connect IGBT with a series diode, extra, it blocks which voltage? Reverse voltage. Up to this for transistor. If it is a series diode, it blocks the reverse voltage. Understood? Then, for example, if it is given like this, okay, a BJT, or you take a IGBT with anti-parallel diode. Yes. If you draw the characteristics for this device, this is I, this is minus I, this is V, and this is minus V. Because of anti-parallel diode, anti-parallel diode means it conducts in, because of anti-parallel connection, both the direction. If you apply forward voltage, this is positive and this is negative. With this polarity, diode is conducting. Diode is conducting. In both the direction it conducts. This positive and this negative. Sorry. With this polarity, diode is under reverse bias condition. Okay. But this voltage is blocked by transistor. That's why total device is blocking or conducting. Blocking. For example, if negative voltage is applied, this is negative and this is positive. With this polarity, diode is conducting, but transistor is blocking. But the total device is blocking or conducting. Then total device is conducting, because diode is conducting. That's why we don't get any characteristics. That's why a BJT or MOSFET or IGBT with anti-parallel diode, up to this BJT or MOSFET or IGBT, up to this characteristics okay. Because of anti-parallel diode, it conducts in reverse direction. If it is a series diode, it blocks reverse voltage. If it is anti-parallel diode, it allows reverse current. Simply remember like this. Inherently, first quadrant operation. If it is a series diode, extra which characteristics you can get? Reverse voltage. If it is an anti-parallel diode, extra which characteristics you can get? Yes, reverse current. Any characteristics are given. Then if any device is given, like that only you can draw the characteristics. Okay. Then you try to draw these characteristics for this device. For example, if it is given like this, if this device is given. You try to draw the characteristics for this one. Let this is 1, this is 1 dash. Yes. You prove that. You prove this. It blocks. This is I, this is minus I, this is minus 3, this is plus 3. Okay. You prove this because of anti-parallel, it conducts in both the directions. Now, if V11 dash is positive, what happen? V11 dash is negative, what happen? That you can prove that it blocks negative voltage and it blocks forward voltage also. That's why it is an example of bidirectional bipolarity device. But it is an example of which one? It is an example of unidirectional bipolarity device. Unidirectional bipolarity device. It is an example of bidirectional bipolarity device. Then it is an example of bidirectional bipolarity device. But it is an example of bidirectional unipolarity. Bidirectional. We can prove this one. We can analyze. Then we can get this characteristics. Understood? Like this, we can draw the ideal characteristics of any power semiconductor device. Understood? This is one concept. Okay? Like this, based on this concept already in competitive exam questions are framed. We will see some problems also in practice session. Okay? This is about how to draw the ideal characteristics of a semiconductor device. Any combination is given. Okay, this is one of the example of composite switch. Combination of two. This is one of the example of composite switch. Combination of devices are given. This is also example of composite switch. Combination of devices are given. Understood?